Hello there. Have you ever wanted to create a fully parametric glass railing in Grasshopper using just a curve? In this Grasshopper script, I'll show you how to generate a dynamic railing system that updates instantly whenever you modify the base curve. For this demonstration, I've drawn 4 distinct curves in Rhino: a straight line, a smooth curve, a polyline, and a polyline with kinks. These represent the most common railing profiles seen in architecture. With this slider, I can pass all these curves through the Grasshopper script, instantly generating a railing system based on its shape. The system is made up of multiple elements: glass panels, a base to hold the panels, a tubular handrail, and its individual knob-like joinery system. I can modify the input curve in any way. I can take these control points, modify this. I can move a single control point, change the shape. I can scale it, rotate it, readjust the shape. And the railing system updates automatically. Just going to do Ctrl Z. I have complete control over the key design parameters using these sliders. I can adjust the railing height. I can modify the base. So you can see I can modify the base height. I can also modify the thickness of the base. As you can notice over here, I can modify the glass thickness. I can modify the glass offset. That means how far is it from the edge of the curve. I can modify that. I can modify the panel sizes. I can modify the handle offset from the sides. I can also modify the handle offset from the top. Here, I have applied the script to a building mass, isolating the boundary curves for railing system, like this. And once I pass them into the definition, notice how the entire railing system is instantly generated. This approach is incredibly efficient for modeling custom design elements that are repetitive across multiple projects, like this railing system. Instead of manually modeling each railing, we can use this adaptive definition to generate complex railings in seconds. Let me walk you through the broad steps that help us generate these railings in this Grasshopper definition. The first step, as you see, is to set up the base curves. I have 4 inputs of curves, and you can use any input. So for example, let me just replace this curve with another curve like this, and I select set one curve. Right, this is just a way for me to control which curves I send as an input, but all you need to set up are these initial curves. Then we pass this profile curve into step 2. Step 2 unifies the curve direction to ensure that all curves are aligned in a way where their offsets are done on the inner side. So what we want are these curves to represent the external edge of the building or the railing, not the internal edge. So whatever output is generated, for example, if this is the curve, let me hide it, let me show you. Whatever output is generated, it's aligned, its outer edge is aligned to the curves that we are providing as an input. So this step unifies the curve direction. For straight lines, this step does not work because straight lines can have a unifying direction in either ways. So in case you're not getting the railing being generated in the desired direction, for example, here this curve is representing a balcony which is over here, and this is supposed to be the external edge, but the output that is being generated is on the other side. In that case, you simply need to select this curve and just flip it. You can use the flip command and it flips the direction, and you see as soon as I flipped it, the curve or the railing direction also flipped. Then the step 3 is to create the railing base curve profile. So we are just creating the base profile for the curve. For example, over here, this is for the railing base. The fourth step is to get the glass profile segmented into panel lengths. So just to demonstrate this, I've got the resulting curve which is currently set at the center of this base, and if I have to explode it, you can notice these segmentations are based on certain distance parameter. This segmentation is based on the panel size. So if I reduce the panel size, I get more segmentations. If I increase it, I get a certain number. So this helps us segment the curve into panels. Step number 5 is to convert the base curve into a B-rep. And this B-rep also has a slot in it for the glass to sit in. This helps hold the glass in position. Now, this is a very simple B-rep. If you wish to make it more detailed, you can work on top of it, make it more detailed, but for the purpose of this demonstration, I've kept it simple as a single slot. The sixth step is to generate the railing, the handrail. So we generate the handrail based on the initial parameters that have been established over here. So we can control the height of the railing, and I can move it up or down. Like this. The seventh step involves creation of individual handles. Now, here we have created this joinery detail where you have this knob system and you have this gap where the glass sits, and then you have this connecting pipe which goes and connects to the handrail. So we create this individual joinery system at the origin and then use the source plane, this B-rep, and generate some target planes on each of the railings. Now the way we create target planes is to look at the individual curves that we have. We convert that into glass panels. There is this cluster which has some additional definition inside it, which will give you two outputs. One is the curve segmented with some gap in between, because as we have noticed in glass railings there is some gap, and you get the glass B-rep, which is the final glass output. So we take these curves, we find a point within these curves that will serve as the position for the knobs. We do some geometry operations, find the position for the knobs within each B-rep, but as you can see it's positioned at the bottom. Then it's moved up to the appropriate level, and then that serves as the target plane. We take this target plane, we take the B-reps that we have generated, or the single B-rep. We have the source plane over here, which is again at the origin, and we use that to orient all the handles. And once the orientation is done, you get all the handles, and together now we have the base, we have the glass, we have the railing pipe, and we have the handles, and all of these together using some custom preview and custom preview line weights gives us the output. And it's totally parametric. And that's it. A fully parametric glass railing in Grasshopper, adaptable to any design input. If you found this useful, don't forget to like, subscribe, and let me know in the comments what other Grasshopper tutorials you'd like to see next. And also, if you want to access this Grasshopper definition along with the step-by-step guide on how to use it, it's available exclusively for my Patreon supporters. Check out the link in the description to support the channel and get access to more advanced parametric design resources.